Hello, everyone. Thank you for coming. Let me start sharing my screen here. Right. So feel free to scan the code for attendance. All right. So welcome to the 5th developer community meeting. We're going to be talking about natural language processing. Pranjali couldn't make it today, but it's fine. All right, so let's begin. So what's on the agenda? So first, we're going to talk about how computers interpret language or words in general. We're going to be talking about preprocessing for natural language processing, or NLP. We're going to be looking at models for NLP, and then we're going to be going into some live code. All right. So how do computers interpret language? Well, the short answer is they don't. So computers don't really understand what words are. Letters to computers are just numbers in an index like ASCII or Unicode that they can display. But the meaning of these letters together doesn't mean anything to them. So for example, some of these words, let's look at some of these letters here, like T. In a Unicode table like this, T would be the hexadecimal value of 0074. Now, the computer doesn't know what the T even sounds like or looks like. It's just printing it out. And that's why, to a computer, if you ever do like a string comparison in any programming language, the word text with a capital T is not equal to text with a lowercase t. So what do we do for preprocessing for NLP problems? Well, first we need some data, and it can be anything from like a book to like some Reddit posts or anything you can scrape off the internet. So what we did in our code, first we lowercased all the text, which, like I said before in the previous slide, the word with like a capital letter is not the same as the same word with all lowercase letters. So to even everything out, make sure there's no like confusion in the model, we lowercase everything. Then we remove white space, like you know how there's a new line character, /n. We remove those and others like those. We also remove the punctuation, and we do this by replacing it with space or nothing. Other steps that can be done, what we didn't do, is that you can remove numbers. This is beneficial if you're going to like sentiment analysis, like you want to analyze, you want your model to analyze whether like a certain piece of text, if it's either positive, negative, or neutral. You don't really want numbers in that. You want words like, oh yeah, it was good, or bad, or horrible. You want those words. You can also remove stop words. And stop words, what they are words that don't really contribute anything to the sentence, like you, your, we, us, and stuff like that. And there's also, what can also be done is stemming or lemmatization. So in stemming, if you look over here, stemming and lemmatization, they're basically two ways of doing the same thing. You're trying to get the root word from a word. So if you see here, there's consign, consigned, consigning, and consignment. The root word in all of these is consign. Just as a disclaimer, after you pre-process your text in an NLP problem, usually it's not very readable to humans afterwards, but that's okay because the computer doesn't care. And so in stemming, you get the root word consign. But in lemmatization, you're not trying to get like this word right here. You're trying to get the word that stems from it. So let's say this word was better instead of consign. The root uh, the root word of better is not better itself, but good. It stems from good. So it would go from better to good. And why would you do that? Well, you want less words to be used in your text, and because that can help the model understand patterns in the text better. Right. So, what are some models for NLP? Well, one of them, well, the fundamental one that we're going to be using today is a recurrent neural network. It's basically like a neural network, but it has a loop in it. And what this does is that it allows the model or the network to store information. And in short, RNNs use their reasoning from previous experiences to inform the upcoming events. That's the definition. And then we have long short-term memory network. This is basically based off an RNN, but it uses memory gates to solve a problem that RNNs had. And this problem is called the vanishing gradient problem. This problem arises from the RNN having too many loops. The gradient that was inside would go all the way to 0, and then you would have really, really bad results. So the RNN, the LSTM solves that. All right, so let's get some live coding going on. And the data we got, it was from this website called Project Gutenberg. And it's a website where you can get free books. I really recommend it if you're doing any type of NLP problem. For in our case, our model is going to be doing text prediction. So it's going to be getting text from us, then it's going to be predicting the next word. But other types of NLP problems is like sentiment analysis or others. It's kind of a new field, but I'm sure there's going to be a lot more problems to be solved in the future, right? So let's get started. We're going to import our libraries, and then we're gonna. What I did was I went to downloaded, went to Pride and Prejudice right here. Went to the plain text ETF, did a Control A and a Control S, and saved it as a text file. Then I imported it into my notebook here using this add icon, upload file. And here it is right here. Now I'm going to read it. And as you can see, here's the entire book, Pride and Prejudice. It's a pretty long book. So let's do some pre-processing. First, we're going to put in, separate the entire book into some lines. And we're going to be lowercasing those lines and adding it to data right here. Then we're going to be replacing the white space, like the new line character, the /R, UFEF is some of the stuff that's in there. And then we're going to be replacing all the punctuation that's in there. And then we're going to be joining it back into data. Right, so here it is. Pre-processed text right there. So tokenizers, what is this? So remember how I said that computers really don't look at words like strings like we do. They look at it as numbers. Well, a tokenizer is going to be converting those words into numbers that our model can understand, basically. So we're going to be using a tokenizer from Keras. We're gonna fit this on the text or data. This line right here, I'm actually saving the tokenizer in a pickle just to open it later if I ever need to use this anywhere else. I'm going to get the size of the vocabulary. This is for our embedding layer that I'm going to talk about later. And then we're going to save everything as sequences. And then we're going to be appending all the words in X and all the words right after the words. So every other word in Y. And we'll have this right here, right? These are the numbers that represent the words. Right, now we're going to create our model. So we're going to be using the sequential class. This is the layer by layer by layer that you're used to seeing. We're going to have an embedding layer, an LSTM layer, and a dense layer. Right, so what does this mean? Embedding layer. So this embedding layer, you can think of it like a space where all the vocabulary is going to be for our book. And if you imagine, you can imagine like a word like empress and girl. These two words are going to have a connection, a vector connection that basically relates them. And this helps the model understand, all right, these words are related to each other and these words are related to each other. We're going to have our two LSTM layers here to learn what words go after each other. We're going to have a dense layer and another dense layer. This is going to basically, well, it's going to be like a line, and then each word has its own probability, and it is going to output the probability of each word. So if I input the probability of a word like the word, or the string, it's going to be higher than the, for example. We're going to print out our model summary here. Now, I'm sorry I'm not executing these cells. This actually took the model I'm going to show you right here. This took like 20 minutes or 30 minutes to train. So I'm being really careful. I use callbacks here to make sure that even if in the middle of training that something happened, I can continue from where I left off. And here it is. We're going to be using it here. And here's going to be our code to actually use it. So let's use it here. So for example, and it says renamed, the renamed. And you can actually make a sentence, hopefully, with this. Renamed, reported, 90. This is why you remove numbers. So basically the sentence that they gave us was name reported 90 group. It doesn't really make sense, but these NLP models, they kind of scale with the amount of data that you give them. So one thing you could do, I'm going to actually send this notebook in the chat, in the Discord chat. I'm gonna recommend you that you can actually get another book for Project Gutenberg. Let's say you get Frankenstein. You can go to the plain text UTF Control A, Control S, save it as a text file, upload it into this deep note. And over here, when you open it, you can actually add it to the lines so that the model has more data. And see, and just run everything else. Go down here and see if you get better sentences than I did. All right. Here's our link tree. If you're not in the Discord yet, please message me on Discord. Send me a DM. My Discord username is over here. Send me a DM. My DMs are open. If you need help, if you want advice, anything, let me know, or ping me in the AI channel if you have any questions. Thank you.